Hi, I'm Chonghua Guo, founder of Chonghua Academy. I will teach you the primer of probability. Now we start lecture class 2, more difficulty counting problems with addition and multiplication mixed. I have taught you our 4M problem-solving approach in our exercise class 1. 4M stands for motivation, method, mechanics, and more thoughts. Now, with 4M approach in our mind, let's look at example 1. As shown as below, there are 2 ways from A to B and 3 ways from B to D. There are 4 ways from A to C and 2 ways from C to D. How many ways are there from A to D? What's our motivation for this problem? Our motivation is to get aware of the number of ways from A to D. Next, what might be our method? Since traveling from A to D is a one-step job, we may conclude that addition method of counting should apply. It's easy for us to identify 2 types of options from A to D. So type 1 is the root ABD, which means ABD from A to B. Type 2, so type 1 is ABD. And type 2 is ACD. However, unlike the problems we met before, both types contain multi-steps. Type 1 involves in 2 steps, with step 1 of A to B. So we can write here, take a note, we got 2 ways A to B, and step 2 of B to D. Type 2 involves in 2 steps, with step 1 of A to C and step 2 of and we got B to D right here is 3 ways. In terms of type 2 ACD, we got from A to C is 4 ways. 4 ways. And from C to D is 2 ways. Under this circumstance, we call it a step in type problem. Multiplication rule should apply first and addition rule apply second. So now we can move to mechanics. And we got mechanics. And to do the calculation for type 1 together, there are 2 times 3 equals to 6 different ways from A to D. And type 2 together there are 4 times 2 equals to 8. 4 times 2 equals to 8 different ways from A to D. Now we can sum up then, which is 6 plus 8 equals to 14. different ways from A to D. This answers the original questions. Now, can we ask ourselves more questions, which is our fourth M, more thoughts. So more thoughts. How many ways are there to finish a job where two types of options with M steps in type 1 and N steps in type 2? Now, let's look at different situation from the example 1, which is more difficulty counting problem 2, type in step problem. So we move to next one. To illustrate it's different, I would like you to look at the example 2. John plans for a business trip from A to B via C. There are 3 trains and 5 buses from A to C. There are 4 trains, 7 buses, and 2 flights from C to B. How many ways are there from A to B? Using the 4M approach, the motivation, so we got the motivation. For John might be interested in how many alternatives for him to travel from A to B. Since he is aware that, so his motivation is to awareness. Numbers of ways. Since he is aware that he needs 2 steps to go to B, so this one is a step, this is 1, this is 2, which is from A to C first and C to B second. The method should be based on multiplication rule. So method could be multiplication rule, as we learned before. However, unlike the problems we met before, each step consists of different types of ways, as we call it as in step problem. For step 1, John may take either one of the 3 trains or 5 buses from A to C. For step 2, John can choose any one of the 4 trains, 7 buses, and 2 flights. So now we can move to mechanics. Obviously, the type in step problems can be calculated by addition rule first and multiplication rule second. So for step 1, together there are 3 plus 5 equals to 18 different ways from A to C. A to C. And for step 2 together, there are 4 plus 7 plus 2 equals to 13 different ways. In total, John has 18 times 13 equals to 104 different ways from A to B. This answers the original questions. Now can we ask ourselves more questions, which is our fourth M. More thoughts. How many ways are there to finish a job where 2 steps with M types of ways in step 1 and N types of ways in step 2? Okay, now we talk about Our next topic, more difficult counting problem 3, graphic approach. In many other situations where counting is not very explicit, graphic approach can intuitively help us address these problems. Let's look at example 3. Three people are taking seats in a row of 8 empty seats in a cinema. How many ways are there if each person sits down with empty seats on his or her left and right hand, respectively? Using the 4M problem-solving approach. 4M. The motivation of these people may be sit down comfortably to watch movie. So motivation is to sit comfortably, sitting down. Since three people are to arranged, we can conclude that multiplication rule should apply in terms of method. So multiplication rule should apply. The problem is it's not apparent for us to count the ways available for each step. So naturally, we want to visualize the problem to see what happens there. So we can draw a circle. Circle stand for empty seats, and we can draw a triangle. Stand for a seat with a person. Seat with a person. Three persons will occupy 3 seats, and will leave 5 empty seats. So let's visualize the 5 empty seats like this. And we got 5 circle. These are the 5 empty seats left. Our task is to insert the 3 triangles standing for seats with persons one by one into the 5 circles standing for empty seats. The first triangle cannot be inserted into the far left, and far right, because there must be empty seats by the triangles left and right. Consequently, we count the numbers of available space in between the 5 seats. So 1, 2, 3, 4, and obtain 4 ways for sitting down of the first person. Let's illustrate this as below. So we can draw a 1, 2 triangle, 1, 2, 3. Now, the first person taking seat. What's next? We continue to count the remaining space for the second person. 1, 2, 3. Now, and obtain 3 ways for the second person. Let's graph it as below. So now we have 1, 2, 3, and we have the the second person arranged. Well, we can turn to the third person and find it's easy for us to find that there are only two ways left for the third person with his or her seat empty. So 1, 2. So we can do it as 1 triangle, circle, triangle, triangle, and we count their all numbers 1, 2, 3, 4, 5, 6, 7, 8. So there are totally in a row is 8 seats. Now we can turn to mechanics and do the calculation with multiplication rule. Together there are 4 times 3 times 2 equal to 24 different ways. Finally, we can move to the more safe sorts. What if 4 people are taking seats with other conditions keeping unchanged? Okay. As the last part of lecture 2, we leave some assignments for you to practice. So you are encouraged to address them before you watching next video, where we will share some possible solutions for them. This ends our lecture 2.